Hello class, it's Mr. Kaplan here, and I'm here to present the first lesson for Chapter 8 dealing with quadratic relations. And I mentioned in the previous chapter, where this chapter starts is where we left off in the last one. The only difference between this chapter and the last one is that we're now going to see why we did this stuff in the previous chapter dealing with things like factoring and the different types of factoring we looked at. So this particular chapter is just an extension to what we covered in the previous chapter here. So let's get straight to it. Now, the first thing we're going to do here, again, today's lesson is going to be a quick introduction in terms of how to interpret what we see on a parabolic curve, which is the graph of a quadratic relation. So if you take a look at the diagram in front of you there of the guy bouncing the soccer ball between his knees, okay, the path of that soccer ball going from one knee to the other, that's an example of a parabolic path, which is defined by a quadratic relation. So again, any type of problems that deal with objects going up and then coming back down are perfect examples of how quadratic relations works in every type of scenario here. All right, so let's get right to it and start off with a little bit of theory here. So in the previous example, I mentioned several times that when you have an equation and you notice there happens to be a letter x, okay, with an exponent of 2 attached to it, okay, this tells you here that that particular equation is quadratic. Okay, so if we drew this, we would wind up getting a curve. So just always look for the x with an exponent of 2, and that's the dead giveaway that what you have there is a quadratic relation. And what we want to do for today, again, is just go over look at some graphs, and then from there, just analyze them to see where we can look in the graph to determine where the answers are for the questions we're about to ask. So first question, believe it or not, does deal with soccer. So if we take a look at this here, is that the path of a soccer ball that was thrown in the air is modeled by the graph, as you can see. The y values represent the height of the ball, and the x values represent the horizontal distance in meters that the ball was traveled. So if you think of any object, whether it's a basketball or a soccer ball, okay, it's always going to go in two directions. It's going to go up and then across. So basically what this graph represents the path in both directions. So you can see here the horizontal distance, okay, is on the horizontal axis here, okay, and the height is on the vertical axis. So again, think of this as the path of the ball as it goes up, reaches a peak, and then touches the ground. And that's exactly what we want to read off for this particular graph here. All right. So for part A, here's what is the maximum height of the ball? Well, the maximum height of the ball is basically the peak before it starts coming down. So that's this point over here. Now the question is, where do we need to read off the graph in order for us to answer this question? So since it's asking for the height over here, what you have to do here is take a look at the point and then read across to the axis that determines the height. So if I go across here, okay, you notice that the height of the ball, it's going to line up with the 9. So the maximum height of this ball is going to be 9 meters. All right. So for part B, it says how far did the ball travel horizontally to reach this maximum height? So we're still talking about this one point here. And what this is asking us is how much did it travel across to reach that height? And basically, we just take that point, and this time we're reading off the horizontal axis. And you notice it says here it's going to travel horizontally for 10 meters. Okay. So notice all we're doing here is interpreting the points on the graph here. Okay. So for part C, is what horizontal distance did the ball travel before hitting the ground? So that's asking us how far it is from where it started to where it landed on the ground here. So if you take a look at what I've highlighted here in red, or in green, sorry, okay, notice what we have here is the green line where we start at 0 and it ends at 22. So the total horizontal distance covered with the soccer ball here is going to be 21 meters, okay? Now, this next part, okay, so typically when you think of a soccer ball, people automatically think that a ball is kicked from the ground. But in this question, it's different. In order for us to determine what height the ball was thrown here, you can see that at the very start, okay, the ball is actually some distance above the ground here. Now, notice it's that particular point is located in between 1 and 2. So we can say it's at 1.5 meters. So and this would be an example of in soccer how you throw the ball from your head and you throw it across. That would be a perfect example of that. All right. So that's interpreting graph and how that relates to quadratic relation here, because what you see here is a parabola that happens to open downwards. All right, let's proceed here. Okay, so if you look at the second example here, we now have an equation to deal with. So it says the arch support of a bridge can be modeled by the quadratic relation y equals negative 0.024x squared plus 2.4x. Okay, and it tells us here y represents the height in feet of the bridge, and x represents the horizontal distance in feet. And the vertical support posts are to be installed at various lengths from the base of the arch. Now, what we're going to do here, we're going to be doing some calculations here. So if you have a calculator in front of you, okay, familiarize yourself with the x squared key, which takes a number and squares it. Otherwise, what you also could do is to find out where your exponent key is. And with the calculators I had in class, it was the y to the little tiny x key there. Okay, and in some cases, you might have a little key that has a little hat like this. Okay, so look for any of those type of keys. All right, so all we're going to do here when you're is to substitute these values in for wherever we see an x. So for the first one here, always start off by writing down the equation, and all we're going to do here is replace the 50 in for the x. So notice that when the 50 is replaced in for the x here, okay, I put brackets around it, and the way we set this up here, and if we did this question here with the calculators provided for you, okay, you should get an answer here of 60 feet. All right, so double check that to see if you get that answer. Again, main thing you have to just be careful with this one when you're putting it in the calculator. Make sure you have the negative in front of the negative of the 0.024, and don't forget you're squaring the first 50 here in brackets. All right, and you're going to do the same thing with the 60 feet. Okay, and for this one over here, you're going to see that we should get an answer here of 57.6 feet. Okay, so again, these is just getting you familiarized to how to put numbers into quadratic relation. And again, just be careful when you're putting these in, especially when you're putting in the exponents, that you are using either exponent key and raising the exponent 2 or pressing the x squared key. All right, and in terms of what we're going to see for today, again, it was a very quick introduction. So I want you to start working in the Chapter 8 review package that I sent out to you. And I will see you in the next lesson.